So let's calculate the average waiting time. So waiting time is calculated as start time minus arrival time. But because this is a preemptive algorithm, we also have to take into consideration the amount of time the process was waiting for other processes to complete. So in this case, P1 started at 0 milliseconds, but it had to wait for P2 and P3 to complete from 4 milliseconds to 10 milliseconds. So that's why we have to calculate its waiting time as, because it arrived at time 0 and started at time 0, the waiting time was not there at the beginning, but in between it had to wait from 4 milliseconds to 10 milliseconds. So this waiting time was 6 milliseconds. Let's calculate for P2. P2 arrived at 4 milliseconds, started at 4 milliseconds, and its waiting time was 0 milliseconds. For P3, it arrived at 6 milliseconds. It started at 7 milliseconds and was not preempted in between. That means it would not wait, executed in one shot, and hence its waiting time was 1 milliseconds because it started at 7 milliseconds, but it arrived at 6 milliseconds. So it was waiting for 1 millisecond. So the total waiting time is 6 plus 0 plus 1, and average waiting time is 2.33. Let's calculate the turnaround time now. Turnaround time is straightforward. It is finish time minus arrival times. So from the process Gantt chart, we get to know that process P1 finished at 30 milliseconds. It had arrived at 0 milliseconds. So its total time that it spent in the system was 30 milliseconds. Process P2 arrived at 4 milliseconds. It finished its execution at 7 milliseconds. So here you can see that it finished at 7 milliseconds, and hence its total time spent in the system is 3 milliseconds. For P3, P3 finished at 10 milliseconds and it arrived at 6 milliseconds. So total time that it spent was 4 milliseconds. So here you can compare, you can also recheck that your values are correct by calculating CPU burst time plus waiting time is equals to the turnaround time for the process. Like for example, for P3 process, the waiting time was 1 millisecond and its CPU burst is 3 milliseconds. So its turnaround time is 4 milliseconds. You can go back in the video and just check these timings. So average turnaround time is 30 plus 3 plus 4 divided by 3, which is equal to 12.33 milliseconds. Now let's go to the next problem. So in this problem, we are given 4 processes. They are CPU burst and arrival times. So we have to go with 0 millisecond, 1 millisecond, 2 millisecond, and 3 millisecond calculations in our problem solved in that order. So at time 0, process P1 arrived with a CPU burst of 8 milliseconds, and hence CPU will be allocated to process P1, and hence its Gantt chart is 0 to 1. Why we are taking only 1 millisecond? Because at 1 millisecond another into the system. So P2 arrives at 1 milliseconds and its CPU burst is 4 milliseconds. But P1 has finished 1 minute of processing, hence its CPU burst will remain now as 7 milliseconds. So the shortest job is P2 and hence P2 preempts P1. So Gantt chart for this problem is at 0 milliseconds P1 started till 1 milliseconds, but at 1 milliseconds P2 preempted P1 execution. Now at time 2 milliseconds, another process enters into the system and its CPU burst is 9 milliseconds. By this time, P2 has finished 1 milliseconds of execution and its remaining CPU burst is 3 milliseconds. Out of these 3 processes, P2 is the smallest job, so it takes up the execution and it executes for another minute. So it finishes CPU burst, and at time 3 milliseconds, the last process enters into the system, and at this time, the process states are as follows. P1 is of CPU burst 7 milliseconds remaining. P2 has 2 minutes remaining CPU burst time. P3 requires 9 minutes of CPU. It has not processed anything, so it is remaining CPU burst is equals to the actual CPU burst, which is 9. And P4 has arrived fresh with a 5 units of CPU burst requirement. So here, out of the 4, P2 is again the smallest. So P2 continues its execution till the 4, and at 4 milliseconds, new processes are entering into the system. So process all the remaining processes as per shortest job first. So till now, 3 milliseconds of P2's work is finished and only 1 minute of work is remaining. So it will execute from 1 millisecond to 5 milliseconds. Then P3, P4, which is the smallest process with 5 CPU bursts. So it will take up the CPU and execute till 10 milliseconds. Then since P1 is 7 milliseconds, it will take up the CPU next and it will execute till 17 milliseconds. And last, P3 being the highest CPU burst process will execute last and it will finish up at 26. So let's calculate the waiting time for each of these. So P1 arrived at time 0 and it started at time 0, but it was preempted at 1 millisecond and restarted at 10 milliseconds. So if you see here, from 1 milliseconds to 10 milliseconds, P1 was in waiting state. So it was waiting for 9 milliseconds. Let's calculate for P2. P2 arrived at 1 millisecond. It started its processing at 1 millisecond and it was not preempted in between. So it was not waiting for any process. So it came and it started execution and finished execution in one shot, and hence its waiting time was 0. Now P3 arrived at 2 milliseconds, but it had started at 17 milliseconds. So if you see here, P3 started at 17 milliseconds. So it was waiting for a total of 15 milliseconds because it arrived at 2 milliseconds and started at 17 milliseconds. So it was in the waiting state for 15 milliseconds. Now let's calculate for P4. P4 arrived at 3 milliseconds, started its execution at 5 milliseconds, and hence it was waiting for 5 minus 3, which is 2 milliseconds. Again, if you see, P4 was not preempted in between, so it finished in one shot. So it is only having arrival time minus, start time minus arrival time is a waiting time. So what is the average waiting time for all processes? The average waiting time is, for the first process it is 9 milliseconds plus second process 0, then third process 15, then last process 2. So addition of all that divided by 4 is 6.5 milliseconds. So all processes have an average waiting time of 6.5 milliseconds. Now let's calculate the turnaround time. So turnaround time is straightforward, finish time minus arrival time. So P1 finished its execution at 17 milliseconds. It arrived at time 0, so it spent 17 minutes of time in the system. P2, on the other hand, finished at 5 milliseconds and it had arrived at 1 millisecond, so its turnaround time is 4 milliseconds. Next is P3. P3 has finished at 26, if you see here, and it arrived at 2 milliseconds. So it was the total time it spent in the system is 24 milliseconds. And for process P4, it finished at 10 milliseconds. If you see here, it finished at 10 milliseconds and it arrived at 3 milliseconds. So total time it spent in the system is 7 milliseconds. And hence the average waiting time comes out to 13 milliseconds. Now let's go to priority non-preemptive algorithm. Priority algorithm, first of all, let me tell you that in priority, processes will be given priority. So here, P1, P2, P3 as usual, and all the three processes are having three different priorities. Now, we have to first give preference to arrival times. First, consider arrival time, then consider the priority. So if two processes arrive at the same time, you have to start with the process which is having a higher priority. If there is a single process arriving at the system ready queue at any given time, then you have to consider that process only for execution. So here P1 has arrived at time 0 and no other process has arrived at time 0. Hence we start the execution of this process directly. So P1 starts its execution and it goes on up to 24 milliseconds. Why? Because CPU burst of P1 is 24 and this is a non-preemptive algorithm. Once the CPU is allocated to a process, the CPU will not be taken back from that process unless that process leaves the system. So here entire 24 milliseconds process P1 gets the CPU attention and it finishes 24 milliseconds. Process P2 and P3 have arrived in the system. At this time, P1 has finished its execution and hence it will not be considered for CPU allocation. Now, out of the two processes P2 and P3 which are remaining for execution, you have to see who is having a higher priority because both are waiting in the ready queue as they have arrived at 4 milliseconds and 6 milliseconds and we are in the time of 24 milliseconds. So right now we have to consider the process with the highest priority. So P2 is having the highest priority. So that's why P2 starts its execution. So first 24 minutes P1 took the CPU time and now P2 has started. P2 continues for 3 minutes 3 milliseconds because its CPU burst is 3. So it finishes and at 27 milliseconds. P3 is the only process that is remaining unprocessed. So it will be given the CPU time for execution and hence the process complete at 30 milliseconds. So let's calculate now the average waiting time for these processes. So the P1 had arrived at time 0 and it started at time 0. So the total waiting time was 0 milliseconds. Then for process P2, it started its execution at 24 milliseconds and it had arrived in the system at 4 milliseconds. So its total waiting time was 20 milliseconds. Similarly, for process P3 started its execution at 27 milliseconds. It arrived in the system at 6 milliseconds. So total minutes it was waiting was 21 milliseconds. Now the average waiting time is 0 plus 20 plus 21 divided by 3 which is equal to 13.67. Remember here that this is a non-preemptive algorithm. Hence, there will be a straightforward calculation of start time minus arrival time. There will be no other calculations as in case of a preemptive. Let's calculate the average turnaround time for this processes. So average turnaround time for each process is calculated as finish time minus arrival time. So from the Gantt chart, we see that process P1 finished at 24 milliseconds and it had arrived at time 0. So total time for it to finish execution was 24 milliseconds. For P2, it finished at 27 milliseconds and had arrived at 4 milliseconds. So total minutes it was waiting was, total minute for it to process was 24 milliseconds. And for P3 finished its execution at 30 milliseconds and it had arrived at 6 milliseconds. So total time that it took for processing was 24 milliseconds. So the average waiting time is 24 plus 23 plus 24 divided by 3 which is equals to 17 milliseconds. So the total turnaround time, the average turnaround time for each of these processes in the system is 17 milliseconds. Let's see another problem. Now this process P1 to P4, we have already seen this problem. We are just going to see it with priority. At time 0, P1 is the only process in the system. So it starts execution. So P1 starts from 0 and it goes on to 8 milliseconds because its CPU burst is 8 milliseconds. Remember that this is a non-preemptive algorithm. So once a CPU is allocated to a process, it finishes its execution and then only leaves the CPU. And that is 8 milliseconds. These are the processes that are there in the system. P1 to P4 all are there, but P1 has finished its execution, so don't consider P1, and also don't consider the arrival times because all processes are arrived. The last process that arrived was at 3 milliseconds and we are at 8 milliseconds. So all processes are present in the system. So out of these three processes that we need to consider for execution, the process with the highest priority is P5. So P5 gets executed and P4 gets executed, which is having the highest priority. P4 starts its execution and hence the Gantt chart is P1 has finished at 8 milliseconds. P4 finishes at 13 milliseconds. P2 finishes at 17 milliseconds because P2 is the next highest priority process and last priority is for P3. So P3 finishes last. So total all processes finish at 26 milliseconds. So let's calculate the average waiting time. So average waiting time here, start time minus arrival time are the only two to be considered. So P1, P2, P3 are the three processes. So P1, P2, P3, P4 are the four processes. So their arrival times are here. P1 started at time 0, it arrived at time 0, so it had a 0 milliseconds of waiting time. P2 arrived at 1 milliseconds and it started its execution at 13 milliseconds. So P2 here has started at, so this is P2, so P2 has started at 13 milliseconds, so it waited for 12 milliseconds. Next was P3. P3 started at, here is P3. So P3 started at 17 milliseconds and it had arrived at 2 milliseconds in the system. So 17 minus 2 is 15 milliseconds. So 15 milliseconds process P3 was in waiting state. In P4, P4 started at 8 milliseconds and it arrived in the system at 3 milliseconds. So total amount of time that it had to wait was 5 milliseconds. So the average waiting time is 0 plus 12 plus 15 plus 5 divided by 4, which is equals to 8 milliseconds. So the average waiting time for all of these processes is 8 milliseconds. Next, calculate the turnaround times. So the turnaround times for P1 to P4 are P1 finished at 8 milliseconds. So P1 process is here and it finished at 8 milliseconds and it arrived at time 0. So total milliseconds that it took for execution was 8 milliseconds. P2 finished at 17 milliseconds. So if you see here, P2 is here and its finished time is here. So finished at 17 milliseconds and it arrived at 1 milliseconds. So total amount of time that it spent in the system was 16 milliseconds. P3 on the other hand, here is P3. P3 finished at 27 milliseconds and it had arrived in the system at 2 milliseconds. So total time it took was 24 milliseconds. And P4 finished at 13 milliseconds. So here is P4. P4 finished at 13 milliseconds and it arrived in the system at 3 milliseconds. So total amount of time that it took for execution was 10 milliseconds. So the average turnaround time for the processes is sum of all divided by 4, which is equals to 14.5. Now let's go to priority preemptive. Now we have seen priority non-preemptive. Now priority preemptive. It means that if the process P2 that arrives after P1, if it is having a higher priority, it will take up the CPU by removing P1 from the CPU. So this is processes again. So let's see, at time 0, P1 arrived at time 0 and at its first time is 24 and its priority is 2. So it is the only process. So it will start execution. P1 started at time 0 and goes on till 4 milliseconds because at 4 milliseconds P2. So at 4 milliseconds, the second process arrived, which is having a priority of 1. By this time, P1 has finished 4 milliseconds of its task and 20 CPU burst is remaining. So now, out of the two processes P1 and P2, the highest priority is for P2. So obviously, P2 gets executed. So if you see here, P2 is having the higher priority. So P2 preempts P1 and starts its execution. So P1 executed for 4 milliseconds and from there onwards, P2 took over the system and executed till 6 milliseconds. Next, at 6 milliseconds, process P3 arrived into the system. At this time, P2 had already finished 2 milliseconds of its task and remaining 1 millisecond was there. And if you see, highest priority out of all the three is again to P2. So P2 continues its execution and it finishes its execution at 7 milliseconds. At this time, P2 goes out of the system. So which is the process next? The next process that will get executed is obviously P1. Why? Because P1 is having a higher priority. So P2 finished all 3 minutes of its execution and its CPU burst is now 0. So do not consider P2 now. So it is out of the system. Now process P1 and P3 are only 2 processes in the system. Now you have to check for priority who is having a higher priority. So P2, as we saw, is having higher priority. So it will start its execution. And that will be continued by P3. So here P3 will follow P1's execution. So P1 started at time 0. It went on to 4 milliseconds. Then P2 executed till 7 milliseconds. P1 again continued after P2 because it was having a higher priority than P3. And lastly, P3 gets executed for the remaining 3 milliseconds. So what is the average waiting time for these processes? So waiting time for these processes is calculated as start time minus arrival time plus the number of times the process was interrupted. So in that case, you need to calculate restarted time execution minus interrupted time or preempted time. So in this case, P1 started its execution at time 0. It arrived at time 0. So this is 0 minus 0 is 0. So this is the first pair. But if you see here, P1 was preempted at 4 milliseconds and it started its execution at 7 milliseconds. So it started at 4 milliseconds and it again restarted. It was preempted at 4 milliseconds and again started at 7 milliseconds. So it was waiting for 3 milliseconds. Next, P2. P2 arrived at 4 milliseconds and it was not preempted, hence it was and arrived at 4 milliseconds. So its waiting time is 0 milliseconds. P3. P3 started at 27. So P3 started at 27 milliseconds. It arrived at 6 milliseconds and it was not preempted. So 27 minus 6 is 21 milliseconds. So the total, you need to calculate the total waiting time divided by 3 to get average waiting time. So it is 8 milliseconds is the average waiting time for each of these processes. Let's calculate the turnaround time. Turnaround time is finished time minus arrival time. So from this process, we know that P1 has finished at 21 milliseconds and it arrived at time 0. So total milliseconds is 27. For P2, it is 3 milliseconds and for P3, it is 24 milliseconds. So the average waiting turnaround time is 18 milliseconds. Let's consider another example. Now in this example, we have 4 processes. Their CPU burst times are 8, 4, 9, 5. Their priorities are 3, 2, 4, 1 and their arrival times are also given. So first you need to consider arrival time and then the priority. start solving this problem at time 0. Only P1 is a process that is there in the system, so it starts execution as always, and it goes on till 1 milliseconds because the process is going to enter into the system. So at 1 milliseconds, P2 has entered and its priority is 2, and hence it will preempt the running process P1. But P1 has already finished 1 minute of processing, so CPU burst remaining is 7 milliseconds. So P2 preempts P1 and hence its the Gantt chart will be as follows. At 2 milliseconds, process P3 enters into the system and its CPU burst is 9 and its priority is 4. It's having a lower priority. Most of the time, the lower the priority number will be the higher the priority, and higher the number will be lower the priority. So you need to check carefully whether lower number is higher priority or higher number is higher priority in the question paper. Please pay attention to this one thing because your problem solution can go wrong based on this decision of yours. So here again P2 is having a higher priority out of the 3 processes. So P2 continues and it finishes its execution for another 2 minutes and 2 milliseconds, and hence its remaining time milliseconds is 2. And now P4 enters the system at 3 milliseconds and its CPU burst is 5 and its priority is 1. Since it's having the highest priority in the system right now, so it will preempt the running process and hence P4 preempts P2 and takes over the CPU for execution. So P1 executed for 1 milliseconds, P2 executed for 3 milliseconds and 2 milliseconds, and P4 executes next 5 milliseconds. So at time 4 milliseconds, no new process is entering. So P4 finishes its execution and then the remaining process based on the priority are executed. So if you see here, P4 was a process that was running. Its priority was 1. So it had a CPU burst of 5. So from 3 milliseconds to 8 milliseconds, it got executed. At the end of 8 milliseconds, it will now go out of the system. So who are the remaining processes? These 3 are the remaining processes. P1, P2, P3. Out of that, P2 is having a higher priority. So P2 gets executed next for the remaining 2 units of milliseconds of time execution that it was remaining. It will finish and it will go out of the system. When it goes out of the system, now P1 and P3 are remaining. Out of that, who is having the higher priority? P1 is having the higher priority. So P1 starts its execution and it takes up the 7 minutes of its CPU burst. And lastly, the P3 executes and P3 finishes its 9 milliseconds in one go. So let's calculate the average waiting time now for these processes. So again, we have the same formula here, and P1 started at time 0 and it arrived at time 0, but it was preempted at 1 milliseconds and it waited. See, from here it was waiting till here. So it waited for 9 milliseconds. So 10 minus 1 is 9 milliseconds. For P2 started at 1 milliseconds. It arrived at 1 milliseconds. So the time that it was waiting here was 0 milliseconds. But if you see, it waited for P4 to finish. So started waiting from 3 till 8 milliseconds. So total amount of time that it was waiting was for 5 milliseconds. Next, P3 arrived in the system at 2 milliseconds. It started at 17 milliseconds. So if you see here, P3 is here and it started its processing at 17 milliseconds. So total amount of time that it was waiting was 15 milliseconds. And P4, it arrived at 3 milliseconds, started its execution at 3 milliseconds, and it did not wait for any amount of time. So it is 0 milliseconds. So average waiting time for these processes is 7.25. So addition of all that divided by 4, because there are 4 processes, so we have 7.25. What about turnaround times? The turnaround times for these processes are, for P1 finished at 17 milliseconds, and it arrived at time 0, so 17 minutes it spent in the system. P2 finished at 10 and arrived at 9, so 9 milliseconds. P3 arrived at 2 milliseconds and finished at 26 minutes, so 24 minutes it spent in the system. P4 finished at with only 5 milliseconds in the system. So total turnaround time is 13.75. So that finishes the priority. Next we go to round robin. Round robin, as I have already explained, round robin is a process where the processes are put into the queue in the first come first serve basis, and the CPU is allocated to each process equally in a time quantum. So supposing if the time quantum is given as 5 milliseconds, then each process is given 5 milliseconds. So if the process has a CPU burst of more than 5 milliseconds, then it repeatedly comes into the system and executes for every 5 milliseconds of time quantum. If the CPU burst of that process is less than 5 milliseconds, then it will quit from the system and allocate the CPU to other processes waiting in the ready queue. Let's see this with examples. Here the question is given with 3 processes, 24, 3, 3, the standard example that we are seeing from the beginning of this session, and time quantum is 5 milliseconds. In this case, process P1 has arrived first, so it will be given the execution time quantum of 5 milliseconds. So first time quantum is allocated to P. Process in the system is P2, so P2 is given the second time quantum. So P1 executes for 5 milliseconds, then P2 executes. P2 has a CPU burst of 3 milliseconds. So before the time quantum finishes, P2 exits the system, and hence P2 the processing to the CPU to other process for execution. So right now, if you see, P2 has finished its execution, so it is out of the system. Remaining 2 processes are P1 and P3. Since P2 has just finished, the next process that has entered the system is P3. So P3 gets the next time quantum. So P3 executes next. Next, at third time quantum, so we have P3 also has finished. Now P1 continues. Now if you see, though P1 is having 19 CPU burst, it will not finish in one go. It will have a context switch for the time quantum. So P1 will be given this. So every time it goes on executing for 5 milliseconds. So if you see here, now P1 executed here for 5 milliseconds. P1 executed here for 5 milliseconds, P2 executed for 3 milliseconds, P3 executed for 3 milliseconds. And from here onwards, P1 only is getting executed. But P1 gets the CPU in time quantums only. The 5 minutes time quantum is a CPU algorithm working for, so it will give the CPU to P1 repeatedly for 5 milliseconds. So that's how the entire processing of all 3 processes will happen in 7 time quantums. So 7 quantums are required to finish these processes. So let's calculate the waiting time for these processes. So the waiting time calculation is start time minus arrival time plus the number of times the process was interrupted. So for P1, P1 started at time 0, was interrupted at and had arrived at time 0. Then it waits for P2 and P3 to finish. for their time quantum or to complete their execution before the end of the time quantum. Hence, it waits for 5 milliseconds to 11 milliseconds. So here it is waiting from 5 milliseconds to 11 milliseconds. So total minutes it was waiting was 6 milliseconds. P2 on the other hand had arrived at 4 milliseconds and it started at 5 milliseconds, so it was waiting for 1 milliseconds, and P3 had to wait for 2 milliseconds because it arrived at 6 milliseconds but it started its execution at 8 milliseconds, as you can see here. So 2 minutes it was waiting. So average waiting time is 3 milliseconds. Now let's calculate the turnaround time. Turnaround times is finish time minus arrival time. So here process P1 finished at 30 milliseconds and it arrived at time 0. So total minutes it was waiting was 30 milliseconds. P2 finished at 8 milliseconds. So here you can see P2, this is when it has finished 8 milliseconds and it arrived at 4 milliseconds. So total amount of time that it was in the system was 4 milliseconds. Then P3 again was there in the system for 5 milliseconds. So total, if you calculate the average turnaround time, it is 13 milliseconds. Now let's see the next example. I think you all can solve this problem. I'll give you a few minutes to solve this problem and then take up this problem for explanation. So time quantum is given here 5 minutes, CPU burst times is 2433 and arrival times is given. Since arrival time is given, you have to consider the process based on their arrival times. Let's see the solution. So process system had P1 in the 0 milliseconds time. So process P1 is the only process, so it starts at 0 and ends at 5 milliseconds because it is the first time quantum. The first time quantum, we have P1 finishing its 5 units of work and hence remaining CPU burst is 19 milliseconds. Since there is no process entered into the system, the second time quantum is again provided to P1. So P1 executes from 0 to 5 and 5 to 10. After 10 milliseconds, there is another process entering the system, P2. P2 has entered the system at 6 milliseconds. So now the CPU is allocated to P2. P2 gets the processing time and hence it finishes its processing at 13 milliseconds and exits. So P3 now has gone, P2 process is gone to 0. Since P2 has gone to 0, processor is allocated to P1 and P1 gets executed for 5 milliseconds. So 13 to 18 CPU is allocated to P1. At 18 milliseconds, P3 has arrived into the system because its arrival time is 15 milliseconds. So next time quantum is given to P3. P3 requires only 3 milliseconds of job to finish. So it finishes at 20 system. And hence, the only process that is waiting in the ready queue is P1. So P1 gets the remaining CPU. The time quantum of 5 minutes is given to CPU and last 4 minutes of CPU burst is given to CPU time is given to P1. So it finishes at 30 milliseconds in this way. So if you see the waiting times, P1 arrived at time 0, started at time 0, but it was preempted for 2 times. At 10 milliseconds to 13 milliseconds it was stopped. It was made to wait, and from 18 to 21 it was made to wait. So total amount of time that it was waiting was first initially 0, then it was waiting for 3 milliseconds, then again it waited for another 3 milliseconds. So total 6 milliseconds it was waiting. On the other hand, P2 started its execution at 10 milliseconds and finished at 13 milliseconds, and it did not wait for other processes, but it had to wait at the beginning because it has arrived at time 6 milliseconds, sorry, and it started at 10 milliseconds, so it was waiting for 4 milliseconds. Similarly, P3 arrived at 15, but it started execution at 18 milliseconds, so total 3 milliseconds it was waiting. So total waiting time is 6 plus 4 plus 3, and average waiting time is 4.33 milliseconds. Similarly, the turnaround time is calculated for each of these processes. We get P1 finished at 30 milliseconds, and it arrived at time 0, so 30 milliseconds. Then P2 finished at 13 milliseconds, arrived at 6 milliseconds, so total amount of time that it spent in the system was 7 milliseconds. Similarly, P3 for 6 milliseconds, so average wait turnaround time is 14.33 milliseconds. I want you all to solve some problems. These are some problems taken from the previous question papers. So please solve these 3 problems. I have here 3 problems. This is the first problem. You need to calculate the average waiting time and average turnaround time for SJF and priority. Since here it is given only SJF and priority and there is no arrival time, so it is obviously non-preemptive algorithm that you have to work on. Here in the next problem, it is clearly given that you have to calculate the primitive versions for SJF and priority because arrival time is given. So remember that whenever there is arrival time, there has to be primitive and non-primitive. So if they have already suggested to any one, then you solve only for the one, primitive or non-primitive. But if primitive and non-primitive is not specified, then you have to solve it for both primitive and non-primitive versions. This is the third problem. So you can solve these problems and submit me on the Google Classrooms, and your assignments will be checked and you will be notified about the correct validness of your solutions. Thank you for your patient hearing.